Okay, we're going to go through our first of two videos for section 14.4, where we are solving trigonometric equations. In this first video, we're going to be solving these equations on a given interval, and it's always going to be the same interval. Not sure that's not working. There we go. So this is what we're doing in the first video. We're going to be solving on an interval, and that will only be on the interval from 0 to 2 pi. So when we solve these equations, we're looking for all the answers that would work in that equation from 0 to 2 pi. So in other words, in one trip around the circle. So to start with, we have 4 times the cosine squared minus 1 equals 0. Just like if this were just an x squared, we try to isolate that first, and then we'll take the square root. So what we're going to have here is cosine squared, after we add 1 and divide by 4, equals 1/4, and that means that cosine of x is going to be, if we take the square root, positive and negative 1/2. All right, so what we're looking for here, if this 1/2 was an uglier number, we'd pull out our calculator and do the inverse cosine of 1/2, but we don't need our calculator for this because we know that x is square root of 3, pi over 3. There we go. Because the cosine of pi over 3 is 1/2. Okay, because of our sine, cosine, tangent, 30, 45, and 50, 60, and we've got 1/2, well there it is right there. The cosine of pi over 3 is 1/2. The thing that we also need to notice here is that this says we are in, this is wherever cosine is both positive and negative because we took the square root. So that means that we're going to be in all 4 quadrants. So we want to put this together now. We want pi over 3 to be used as a reference angle in all 4 quadrants. So the answers to this problem would be pi over 3. Let's do a little sketch here, why not? We would have pi over 3 right there. In quadrant 2, we would have 2 pi over 3. In quadrant 3, we'd have 4 pi over 3. Because remember, this is 3 pi over 3. So if I'm pi over 3 short, I'm going to be at 2 pi over 3. If I'm pi over 3 past 3 pi over 3, I'm going to be at 4 pi over 3. And then in the 4th quadrant, I'm at 5 pi over 3. Okay, so those are our 4 answers because they are the answers from 0 to 2 pi. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those 4 answers are all solutions to that equation for x. Now, we could check any of these answers, and I have a little blurb about checking solutions up above here. We could check any of these solutions by putting them into the equation. So, for example, let's just use example 1 here to show that. And not that we would do this for every problem, but just so you see that any of these would work. Let's just randomly pick any of these 4 answers. I'm going to pick that one, 4 pi over 3. That 4 times the cosine of x squared of 4 pi over 3 minus 1 equals 0. Well, the cosine of 4 pi over 3 is, since it's in the third quadrant, with a reference angle of pi over 3, we're looking for cosine, so it's a negative in the 3rd quadrant. And the cosine of pi over 3, its reference angle is 1/2. And now notice how any of these would now be giving us the same thing there, because some of them are positive, some are negative, but we're going to square it so it doesn't matter, and they all have a cosine value of 1/2 because they all have a reference angle of pi over 3. So all 4 of those would have given us the same thing. It would have given us either positive or negative 1/2. So really this could have been any of those answers from down below. Okay, and then when we square it, we get 1/4. So we have 4 times 1/4, which is 1 minus 1 equals 0. Just go like this. Running out of room here. There, it worked. Okay, so we won't always be looking in all 4 quadrants. In this problem, we did because of the positive or negative. Looks like that might happen in this next one too, because we have a sine squared here. Let's see what happens. Let's isolate this and then take the square root. So we're going to have subtract 2, divide by 2, and now we'll take the square root, square root of 1/2. This is 1 over the square root of 2, which becomes square root of 2 over 2, which is what I have right there. If you rationalize, I think we're kind of used to that process though now. We took the square root, so we do need that positive or negative, which means we're going to be in all 4 quadrants. So what angle has a sine value of square root of 2 over 2? Well, that's pi over 4. And we're going to be in all 4 quadrants again because of the positive or negative there. So pi over 4 in all 4 quadrants, let's just run through what that would look like. We'd have pi over 4. This is 4 pi over 4. So then this would be 3 pi over 4, and this would be 5 pi over 4. Because I'm going a pi over 4 in each direction there. And then our last one would be pi over 4 short of 8 pi over 4, so this is 7 pi over 4. And hopefully some of us are to the point now where we don't even need to do this anymore, and we just remember what those angles are. Oops, I lost my 4 there. So our answers to this problem are all 4 angles that have a reference angle of pi over 4. I always like to give my final answer in order from smallest to largest, these angles. Okay, clearly this one looks a little bit more complicated. I think some factoring is going to be involved here, so what I'm going to do is subtract that 7 cosine x over. So if I have 3 and I subtract 7, I have negative 4 cosine of x's. And I have cosine of x, cosecant of x squared, and that equals 0. And then what I see here is a common factor of cosine of x here that I can pull out of each of these terms. So I have cosine of x as a GCF, which leaves me with cosecant minus 4. Then we'll set both of those equal to 0. So I have cosine of x equals 0. And we have this guy here, the cosecant of x squared minus 4 equals 0. Let's take a look at this cosine of x equals 0 first. Okay, picture a unit circle. Where does cosine equal 0? Well, it equals 0 at pi over 2, because that would be 0, 1, and 3 pi over 2, because that would be 0, negative 1. So this equation gives us 2 pi over 2. This other equation gives us, let's see, if I take the square root here, we got positive, negative 2. So we're looking for where cosecant would be positive and negative 2. Well, I know cosecant is the reciprocal of sine. So if I had my big table with all the values in it, I could kind of think through that. Or I could say right now, well, I know that cosecant is the reciprocal of sine, so I'll take the reciprocal of both sides. Oops, sorry. I'll take the reciprocal of both sides. The reciprocal of cosecant is sine. So I have sine equals positive negative 1/2. So that means that x has to be the angle whose sine value is 1/2. That's pi over 6. And since it is positive and negative, we are looking in all 4 quadrants. Okay. This hasn't happened in any of these problems yet, but let's just say we didn't take the square root. And let's just say this would have been negative, okay, just as an example. Then your answer would have been pi over 6 as a reference angle wherever sine is negative, which is anywhere in the third or fourth quadrants. Okay, so we would have said pi over 6 in quadrants 3 and 4, and our only answers would have been those angles in quadrants 3 and 4. But we didn't have that in this case. We had both positive and negative, so we're going to be in all 4. I think we have some on the back side that end up being in just one or two different two quadrants. So pi over 6 in all 4 quadrants leaves us with pi over 6, 5 pi over 6, 7 pi over 6, and in the fourth quadrant, pi over 6 short of 12 pi or 12 pi over 6 or 2 pi would be 11 pi over 6. So I'm going to list these all in order here now for my final answer. Okay, so my final answer to this problem is these 6 angles, pi over 6, and then pi over 2. I'll put them in order here. And then 5 pi over 6, 7 pi over 6, 3 pi over 2, and then finally 11 pi over 6. We have 6 different answers to this equation here. All 6 would work in the original equation. In our next video, we're going to find what are called general solutions, which basically kind of start in the same manner. But what we're going to do is then use these answers that we're getting here to generalize and give an infinite number of answers to that equation outside of the interval from 0 to 2 pi.